we did do a little bit of this worksheet as part of our do now. So I'm just going to pull this up and I want to open the floor to you guys and ask if there were any of these that gave you trouble, or have we completely forgotten how to solve by elimination, or did we feel great about it? So I would love some input. What are you guys thinking after looking at this worksheet? We need some review. Okay, we're in the same boat. Okay, good deal. So we'll definitely be doing that today. So before we, I guess, run through some of these, let's talk about how we actually use elimination to solve an equation. Whenever we are looking at solving for x and y using two equations, and we want to use this elimination method, remember that the very first thing we're trying to do is either get rid of the x values or get rid of the y values. So if we're looking at number 1, does it make more sense to try to get rid of the x's here or the y's here? The y's. Now, why does it make more sense to get rid of the y's first? Yeah, absolutely. So to get one of the variables to cancel, we need to have the same number in front of it, or the same coefficient. So I have 18y and negative 9y. Well, negative 9 times 2 is negative 18. So I know that I can get these to match really easily if I just multiply my second equation times 2. So looking at my second equation, if I multiply all of my terms by 2, what do my new terms become? Negative 5x is now what? Good, negative 10x. Negative 9y times 2 is negative 18y. Bring down my equal sign, and negative 1 times 2 is negative 2. Good. So I've just multiplied all my terms in that equation. What should I do next? Get rid of the 18s. I'm going to do that by stacking these two equations on top of each other and adding them together. So I'm just going to rewrite my first equation. 9x plus 18y equals 9. And we're going to work this like an addition problem. So I'm going to look at my x's first. I have negative 10x plus 9x. What will that leave me with? Negative x. Perfect. And now I have negative 18y plus 18y. What happens there? They cancel out, which is where the elimination part comes in. We just eliminated the y's. So I'll bring down my equal sign next, and now I have negative 2 plus 9. What does that give me? 7. Okay, have I solved for x? Almost. I solved for negative x. I need x. What do I need to do? You can divide by negative 1 here, because we know that this really just means negative 1x, and I want positive x. Another thing we can do, as this is kind of a trick, if you end up with an answer like negative x equals 7, it really means x equals negative 7. Because if I were to divide this by negative 1 to get x, 7 divided by negative 1 gives me negative 7. So if it makes us feel a little more secure about that, we can write out that we divided by negative 1, but we end up with x equals negative 7. Okay, now before we move on to solving for y, does anyone have questions, confusion, unsureness about how we got here?
Do we always, whenever we write out both the columns, will we always treat it as addition?
Yes, always. You're always treating it as addition, and you're just keeping in mind that if there is a negative number, you're technically subtracting, but it's adding a negative number. So yes, we are always using addition for elimination. Okay, any other questions?
Will we always start with one?
Will we always start with y?
Or does it just pick?
That is a really good question. It really just depends on what the numbers are in front of your variables. Like for example, if I were to look at number 2, now it looks like my x's will be easier to cancel because I could do 4 times 3 to get 12. But 8 and 3 for my y's aren't going to be as easy. I would have to multiply both equations to get them to match. So it really depends on which numbers are given to you in your problems. Okay, so we've solved for x. How do I solve for y? We're going to plug in our x value. Does it matter which equation I use at this step? No, I can use either one. I'm going to use the top one just because it's positive numbers. So I have 9x plus 18y equals 9. And instead of x, because I just solved for x, it's -7, I'm going to write -7 in the spot that my x originally was. So now I have 9 times -7 plus 18y equals 9. So what should I do here?
9 times -7.
Yes, what is 9 times -7?
-63.
Perfect, -63. Bring down plus 18y equals 9. And what variable are we solving for here again? Y. So I'm trying to get y by itself. What's the next step I could take to get y by itself?
Add 63.
Add 63 to both sides. Perfect. Okay, so my 63s will cancel. I'm going to bring down 18y equals, now I have 9 plus 63, and I got 72. And what would our last step be? Divide. We're going to divide by 18 on both sides. And 72 divided by 18 gives us an answer of y equals 4. So if I wanted to write this as a coordinate, what would my coordinate be?
-7.
Good. -7, 4. That is number 1. So we're picking one variable to eliminate by multiplying the equation. We add them together, we solve for a variable, we plug that in, we solve for the other one. Okay, before we do another one, do we have any questions about number 1? Well, let's go ahead and move to the next. And as we go, don't be scared to interrupt me. If there's anything that I'm writing that you're not sure why I'm writing it, tell me. Okay, number 2, we have 12x minus 8y equals 20, and -4x plus 3y equals -9. Which variable should we try to eliminate here? Let's try to eliminate x. Okay, so how can I do that? How can I get both of these to be the same number?
All the numbers can be it's 3.
3.
3 or 4.
Right. So let's multiply our second equation by 3 so that I get -12x as my x value. So I have now -12x plus 3y times 3. What is that? 9y equals, and now I have negative 9 times 3, negative 27. Perfect. Okay, so I've got my equation all written out. I'm just going to rewrite the top one underneath so that we can add them together. 12x minus 8y equals 20. Okay, so I've gotten it all written out here. What's going to cancel when I add these together? My x's. Negative 12 plus 12 is 0, so they cancel. Okay, so moving on, now I have 9y plus negative 8y. What does that give me? Y. Perfect. So I'll drop down my equal sign. Negative 27 plus 20. What's that? 7, negative 7. Good. Okay, so this time I solved for y. I got y equals negative 7. Since I have a y value this time, when I plug this into my original equation, either one, I need to make sure that I'm putting it in the right spot. Yes.
So we did 9 minus negative 8, right? Well, not 9 minus 8.
Yes.
So it's 20, right?
Yes, yes. So we got 9 minus 8 is 1y, and since there's a variable, we can just write y without the 1. Yes. You could have wrote 1y and divided by 1, but it wouldn't have changed the negative 7. It'll still be negative 7. Okay. So let's look at which equation do we want to plug this back into? Top one? Let's do the top one. So I have 12x.
Does it matter which one you plug it into?
Yes, it does. Because I solved for y, if I put negative 7 in for x and try to solve for y again, I'm going to get a wrong answer. Okay. We're only going to put it into whatever value we just solved for. Yeah, between the two equations, though, I can use either one. Okay, that's fine. Okay, okay. I thought you meant, can I put this in for x? Yes, yes. Exactly, perfect. So I'm going to write 12x minus 8, and I'll leave a space for my y, equals 20. Okay, and what am I writing instead of y? Negative 7. Okay, so what should I do first now that I have it all plugged in? We're going to multiply. I have negative 8 times negative 7. Yeah. Positive 56. So let's rewrite that. Bring this down. 12x plus 56 equals 20. What do I do next?
Subtract.
Yes, subtract 56 from both sides. We'll let those cancel. And I'm going to bring down my 12x equals 20 minus 56, negative 36. Okay, and I've got one more step. Divide. I'm going to divide by 12 on both sides. And I will get x equals negative 3. Perfect. So if I wanted to write this as a coordinate, what would that coordinate be? Perfect. Negative 3, negative 7. Yes, the x value always comes first in a coordinate and then the y. It doesn't matter which variable you solve for first, but in your coordinate, it will matter what order you write the numbers in. That's a good question. Okay. Now, let me look ahead. See if there's one that we could look at. It's a little different. Number what? 5. Yeah, let's look at number 5. Okay, so go ahead and turn your page. And now we're going to look at number 5. Now, for number 5, we could absolutely eliminate the x's first or the y's first. They both have pretty easy numbers to match up. I've got 3x and 6x. I know 3 times 2 is 6. I've got negative 5y and negative 15y. Well, 3 times 5 is 15. So I could do either one, but there is an extra thing that we're going to have to keep in mind here whenever we multiply one of our equations. First, let's decide, are we going to try to eliminate the x's or the y's? Either one will work. Let's do the x's. Okay, so if I want my x values to match, I need to get my 3x to somehow cancel out 6x. So what does my new x value need to be? Multiply by 2. We can multiply by 2, so that'll make this 6x and 6x. But Cody, you said negative 2. Should we multiply by 2 or negative 2? Yes. So we actually want to multiply by negative 2 here. Why are we using positives in the previous one, but now we need to use a negative here?
Because the x's have to cancel out. So you have to have a positive.
Yes, thank you. The x's need to cancel out. If they're both 6x, they're both positive 6x, when I add my equations together, that's going to give me 12x. It actually will not cancel. The reason we didn't have to multiply by a negative number in these last two problems is because whenever I multiplied, like in number 1, I started with a positive 18y and a negative 9y. When I multiplied that by 2, I got negative 18y and positive 18y. They canceled because they had different signs. Same here with the 12s. I have a negative 12x and a positive 12x. They only cancel because they have different signs. Because when I add negative 12 to positive 12, that equals 0. So looking back at number 5 now, both of my x's are positive. So that means we need one of them to be negative so that they cancel. So we're going to multiply by negative 2. And let's go ahead and do that. 3x times negative 2, what will that give me? Perfect. Negative 6x minus 5y times negative 2. What will that change to? 10y, positive 10y. Those two negatives cancel. Bring down my equal sign, and now I have 1 times negative 2. Negative 2. So we distributed that negative 2 to all 3 terms. And now I'm just going to rewrite that second equation. I have positive 6x minus 15y equals negative 3. And now we're going to add these together. So now that these are all lined up, sometimes seeing them on top of each other makes it easier to see why you need a negative. because if I'm adding -6 plus 6, that will cancel. If this was positive, it wouldn't work. So let's go ahead and cancel those x's. Now my y's, I've got positive 10y minus 15y. What will that give me? Yes, -5y equals -2 plus -3. What's that? Also -5. Perfect. Okay, and now I have one more step here. What do I need to do? Divide by -5 on both sides. And as my answer, I'll get y equals what? 1. Perfect. Y equals 1. So I've solved for y. How do I solve for x? Mm-hmm.
Either one of the x's.
Yes. We're going to plug in this 1 to one of the equations up here. I'm thinking the top equation because the numbers are smaller and positive. Is anybody opposed to that? Okay, let's use the top equation. So I've got 3x minus 5, I'll leave a space for y, equals 1. And what was my y value? 1. So now to solve for x, the first thing we'll do is simplify that multiplication where we plugged in y, just like we've done on the other problems. Since it's -5 times 1, we're just going to have 3x minus 5 equals 1. And then we have 2 steps to solve here. Perfect, plus 5 on both sides, that equals 6. And one more step. Divide it. And I get x equals 2. So y is 1, x is 2. And what would our coordinate be?
2, 1.
2, 1. Good. Okay, so that's number 5. Looking through this worksheet, are there any others that you might like to run through together as a class?
I keep getting tripped up on. Okay, so hold on, let me find where I was here. On the 3x minus 5, I keep wanting to plug that number back into the x.
I know it. I know it. That I'm sure that's a common thing. I honestly think it's because we're so used to x.
So is it the same thing as we're kind of flip flopping it? Okay.
Yes.
I just keep in that x factor.
Right. I think one of the hardest things is like as you're going through this long process of solving, staying mindful and aware of each step. It's so easy to go into autopilot and be like, oh, I know what I'm doing.
Because we solve for y first, so
Yeah.
my brain wants to go.
Right, right. That makes a lot of sense. So I think that's just going to come more naturally with more practice, more problems, just being aware of it. The fact that you're recognizing it is great, and I think it'll only improve. Let's see. Number 9. Let's look at number 9. Okay. Yeah, that also helps for sure. Okay, so let's look at number 9. We could do either x or y. We always can either do x or y first, technically. Just depends on how much work you want to put into it. Which variable do you guys want to try to cancel here, x or y? I think x looks easier. So for x, are we going to multiply the top or the bottom equation? Top. What should I multiply by? 2. Okay. So when I multiply by 2, that'll turn 4x into 8x. Minus 6y times 2 becomes what? Perfect. Negative 12y equals 8 times 2 is 16. Okay, and then I'm just going to rewrite my second equation. Minus 8x minus 12y equals negative 16. It's interesting. They all match. Let's see what's going to happen here. So, what should I do? What's going to cancel?
Everything.
Will everything cancel? It looks like it might. There's one thing that won't. They cancel if the signs are different. So let's look at one at a time. 8x minus 8x. What happens there? They cancel. Now I have negative 12y plus negative 12y. Aha! Negative 24y. Why didn't these cancel? Yeah, because we're adding and because it's the same sign. If I had a positive 12y and a negative, they would cancel. But we have two negatives. So they don't cancel. They're the same sign. Okay, I brought down my equal sign. Now 16 minus 16, what's that? 0. Now, why am I going to write 0 instead of crossing these off? 0 is still a number, absolutely. If I didn't write 0 here and I just left nothing, negative 24y equals nothing, I wouldn't be able to solve this equation. But if I start with positive 16 and I take 16 away, I can have 0. That's an answer. The reason we cancel out stuff like 8x minus 8x is because bringing down a 0 over here wouldn't help us. 0 is not helping us unless it's the only thing left, like in this case. So, Dylan, what would I do from here? Divide by negative 24 on both sides. So those cancel. I'll bring down my y equals 0 divided by negative 24. What's that going to give me? 0. Yes. Zeros tend to throw us off. I think because, I mean, seriously, we forget that it is a number. 0 is a number. If you try to divide anything under 0 or multiply under the 0, it's not. It's going to stay 0. So we got y equals 0 here. So what should we do next? Solve for x. Okay, do we want to use the top or the bottom equation? Let's use the top one. So now let's be careful as we're plugging in our values. I've got 4x. Is that where I'm going to plug 0 in? No, I'm going to keep my x because I'm putting in a y. 4x minus 6y equals 8. And my y value we found was 0, so that's what I'm going to put in here. And now that we have our 0 plugged in, remember we're always going to do this multiplication problem first. So negative 6 times 0, what's going to happen? is gone. That 0 gets rid of the negative 6. So we can go on to solve this problem as 4x equals 8. Okay. And we only have one step to do from here. What is that? Divide. We're going to divide by 4 on both sides. Hello, hello. Okay, and then we get an answer of x equals what? 2. Good. We are, we're solving equations by elimination. We're not simplifying anything necessarily. Oh, you're good, you're good. All right, so x is 2, y is 0. What's our coordinate? 2, 0. Oh, Ricky, I'm wrong. Guys, are you serious? The x comes, wait, no, wait. Making me question myself. Get out of here. It is 2, 0. X comes first, then Y. Swear.
So what was it that we learned last week? It was like the 0 had to go first, right? Is that not what you said?
You're thinking of an x-intercept and a y-intercept, you think?
Maybe. I don't know. I know she kept telling us that the 0 had to go first.
I think you're thinking of a y-intercept because if I had a point on a graph like this, I'm going to draw a little graph, and here's my y-axis, and it's right here, and this is my x. Let's say this is like 2, 1, 2. My x value is always 0 when I'm touching the y-axis. So this would be 0 too. All right. It's all right, keeping us vigilant. Okay. Okay. Any questions about number 9? Let's do another one together just to make sure we got it. Number 6? Yeah, let's do number 6. Okay, so on the second page, looking at number 6 now, I have negative 4x plus 4y equals 0, and then I have negative x minus 2y equals negative 24. So using elimination, which variable looks easier to cancel out, the x's or the y's? The x's? We can do either one. So if I want to make the x's cancel, what am I'm going to multiply one of these equations by a number to make the x's match. Okay, if I'm canceling the x's, we're going to need to multiply by 4. If I'm doing the y's, we can multiply by 2. Either one will work. Absolutely, either one will work. I'm going to start showing you the first method that I saw that looked easiest, which was actually the y's, because I won't have to multiply by a negative here. If I multiplied everything by 2, that would give me negative 12. 2 times negative 2 is negative 4y. And then 2 times negative x would be negative 2x. Now I have plus 4y and minus 4y. And when I add these together, they would cancel. We see that? I could do the x's. Now, if I decided, let me get a separate piece of paper. I'm running out of room. Let's see. Negative 4x plus 4y equals 0. Negative x minus 2 is negative 24. Okay, so if I wanted to cancel the x's out, what would I need to multiply by?
Hold on, wait a minute. X minus 4y
Equals negative 12, yes.
negative 24 times 2 is negative 12.
Girl, I'm losing it. Yeah. Negative 48. Gosh, I'm like all thrown off now. Not bad. Yeah, come on. Okay, so now let me ask you guys this. If I wanted to cancel the x's out instead, what would I need to multiply by? By 1? If I multiply the second equation. So I'm looking at this problem from the very start again. These are the original equations. I'm showing how would I cancel the x's instead of the y's. I want to make sure that we understand what we would need to do. How do I get negative x to cancel negative 4x? Yeah, I need this to be positive 4. So what would I multiply this by to get positive 4? Negative 4. Because negative x is really just negative 1x. Negative 1 times negative 4 gives us positive 4. So this is another option. We could multiply everything by negative 4. This would give us 4x. Negative 2 times negative 4 plus 8y. Negative 4 times negative 24. 24. Let's see. That would give us positive 96. Okay. And then we would just bring down the other equation and add them together. So I'm going to write down both of the methods that we've got going here. We've got this one, and we also have the one where we decided to cancel the y's instead. Negative 4x plus 4y. So now I'm going to rewrite this one where we times 2 to get negative 2x minus 4y equals negative 48. Okay, bear with me a second. Just writing this down again. Okay, so there's two different scenarios here that I have written down. Both of these are valid ways to start solving this problem. Do we see the difference between what's happening in both of these examples? Yeah, we're switching the number that we're multiplying by, and that's going to change which variable cancels out in this first step. So if I did this scenario where I multiplied everything by negative 4 and I add my equations together, what happens to my 4x minus 4x? Cancels. 8y plus 4y. What's that? 12y equals 96. Okay, and last step, what do I do? Divide. Divide by 12, and I get y equals 8. That's my first coordinate, my y value. Now, what's kind of cool about knowing that you can cancel it in two different ways is watch what happens when I solve my next set of equations here. Now I multiplied everything by 2, and which variable is going to cancel this time? Negative 2x plus negative 4x. What does that give me? Does that cancel the x's? No. What's it turn into? Negative 6x. Good. Now, negative 4y plus 4y, what happens? They cancel. Bring down my equals. Negative 48 plus 0 is just negative 48. Negative 6, yes. 48 divided by 6. They're both negative, so they cancel, and we will get an answer of what? 8. So look at this. Instead of plugging it in, you could do two different problems. X equals 8. Y equals 8.
I got negative 8 for y.
Negative 8 for y. So let's start right here. What did you get for x? Because you did it this way, right?
For x, I got 8.
Okay. And then how did you solve for y?
Let's see. What did I do?
Did you plug it back in?
4x plus 4 times 8 equals 0.
Okay, let me see what that would do. So negative 4x plus 4, plug in 8 for y, equals 0. So let's do that and see what happens. Okay, so 4 times 8.
32.
What is 32? So I have negative 4x plus 32 equals 0. And what would I do here?
I cancel out because it's 0.
Mm-hmm.
So then I divided negative 4 on both sides.
So if I divide before I bring the 32 over, yeah, that's okay.
Negative 32.
Yes, and that'll give you your positive 8. So then we would get negative 4x equals negative 32, divide by negative 4. The two negatives cancel. We get x is positive 8. There we go. Okay. So something that I think we've also kind of discovered by showing the two different ways here is that when you're using elimination, if you really wanted to use that method to solve for x and solve for y, you don't ever have to plug anything in if you don't want to. You can technically eliminate the x's to solve for y, and then start all over, eliminate the y's and solve for x. That is an option and it will work. You don't have to do it that way. You don't have to do it the original way. Whatever makes the most sense to you. Yes. Yeah. Okay, so now let's show how to check your answer, because that's a really great thing to be able to do. So we got 8 for x and for y. So if I plug in y and x, either one into either equation or both of them into either equation, I'm going to get a true statement if they're the correct answers. So here's how we can check. Let's start with the first equation. Negative 4x plus 4y equals 0. So negative 4x plus 4y equals 0. We're going to plug them both in. So x was 8 and y was 8. So if I wanted to check and see if my answer is correct, here's how we would do it. What is negative 4 times 8? Good, negative 32 plus positive 4 times 8 is also positive 32. Bring down my equal to 0. What is negative 32 plus 32? 0 equals 0. Is that true? Is 0 equals 0? It's true. It's true. So that means that we have the right numbers for x and y. We can do it with the other equation too. I'm going to write down the other one and we'll try it. Now we have negative x minus 2y equals negative 24. Let's try it. Negative x. Well, our x is 8 minus 2y. Well, our y is also 8. So let's see. I'm just going to bring down my negative 8 because that's what that is. Minus 2 times 8. What is that? Negative 16. Bring down my equal to negative 24. Now what's negative 8 minus 16? Negative 24. Is negative 24 equal to negative 24? Yes. So our answer is correct. So thank you for bringing that up, Cody. I forget you can do that. You have your own way to check check your answer. You will know immediately by doing this if you got the right answer. Because if you get the wrong answer, these won't be equal to each other. And you'll be able to see that and know that you need to fix something. So, very, very nice. Very good. Okay, any questions about all of that? Any questions at all? How do we feel about the elimination method on like a scale of 1 to 10? What's our confidence level right now?
I think it's the easiest and less work for that.
About a 5, easiest. You think that one's less work? Okay, good, good. Does anybody still feel completely lost?
Well, I just haven't.
I get you. I get you. We can absolutely do some review here in a little bit. Would everybody be okay if we go back and kind of look at the other 2 methods and just make sure we understand all 3 of them? And then my plan after that is to get you an exit ticket and hopefully get you out of here a little early. Okay, so let's just make sure we understand all 3 of the methods. So we have elimination. We also have substitution. And then we have solving by graphing. Now.
So we gotta learn all 3 of them?
Yes, we've been learning all 3 of them.
I got the graph down.
That's good. Substitution's not too hard. It's not too hard. We're just going to review that today, and I'm happy to help. Okay. I believe you all already have this substitution worksheet. I will put extra copies over here in case anybody doesn't have that. But let's just make sure that we remember how to solve by substitution. And then we'll make sure we remember how to solve by graphing. And then we'll get out of here. Okay, so let's pick a random one. Yes. How about number 5, maybe? And I think I actually want to do it on a separate piece of paper. Yes, yes. So, and I'm going to give you the problems anyway. So let's practice substitution. We've got y equals 4x plus 10 and y equals 2x plus 4. This is number 5 on the substitution worksheet. Yes. I don't think so. I actually like this method the best for whatever reason, but it just depends on how your brain works. So whenever we're using substitution, what's our first step? We can pick one of our equations. What am I gonna do with the equations? We're gonna set them equal to each other. So as a reminder, we have 2 halves of each equation. There's a y, and then there's an equals something x plus something, okay? This second half of each equation, both of these are equal to y. Y is y. It's the same. If I can say that they are both equal to the same thing, then they are both equal to each other. So what we can do is set these equal. 4x plus 10 equals 2x plus 4. That's the first step. We just take the second half of each equation, set them equal to each other. Now, I think some people don't like this method as much because we have to combine like terms. And I think that scares us a little bit. So, the first thing I would always do after you've set them equal to each other is get all your x's on the same side of that equal sign, because once you do that, it's a lot easier to solve. So I have 2 options here. I could subtract 4x or I could subtract 2x. Which one makes more sense? Yes. Let's get rid of 2x, minus 2x on both sides. And those 2x's will cancel. Now here's where we want to be extra careful about where things get brought down. It's never a bad idea to put that line in between your equal sign if it helps you. So I've brought down my equal sign, and now I've got 4x minus 2x. What does that give me? 2x. I'll bring down my plus 10 equals what's left over here? Just 4. And now I have 2x plus 10 equals 4. What should I do?
Subtract 10.
Yes. Subtract 10. Now, why don't we divide by 2 yet? Yeah, so basically, whenever we're combining like terms, we're talking about the x values and the non-x values. In this part of the problem, I have all my x's on one side, but my numbers without x's, my 10 and my 4, they're not on the same side as each other yet. I need to bring 10 over here with my 4. Then I've got my terms separated. So my 10's cancel. I'll bring down 2x equals 4 minus 10 is negative 6. And now we can divide by 2. And what will my x value be? Negative 3. Good. Okay, so substitution. Our first step is done. We've solved for x by setting equations equal to each other. How do I solve for y? Yes, I can choose either one of these original equations, and I am going to replace the x in that equation with the value I just found. So I think I want to use the second equation because my values are smaller. So now I'm going to rewrite this problem, but instead of x, I'm going to write negative 3. So y equals 2 times x plus 4. And instead of x, again, we're writing negative 3. So where do I go from here? And what's that give me? Negative 6. Bring down my plus 4. And what is negative 6 plus 4? Negative 2. Y equals negative 2.
So it's solved.
It's solved. That's it. How can I check my answer if I want to see if I got it right? That's right. I can plug the y's and the x's into the y's and the x's. Either equation would work. So just for fun, let's do that. Y equals 2 times x plus 4. I'm just checking my answer. This step is not necessary, but sometimes it helps. So where do I put my negative 2 in this equation? Before the equal sign. Y equals negative 2. So negative 2 equals 2x. X is negative 3.
So this is just a way of.
This is the way to check your answer now.
Why are we doing
this part right here?
The graphic, or it's just something totally.
The substitution method?
Yeah, I guess.
So like, why are we solving for x without the graph?
Yeah.
That's a really good question. It is, I don't know, it's part of our math curriculum, and I'm teaching it to you. So, sometimes that's the best answer I can give you. Yes. You're right. It's a way to figure out your x and y without having to graph it. So it's, the algebra version versus the more visual version. Okay, so let's make sure our answers are correct. What's 2 times negative 3? Negative 6 plus 4. Bring down my negative 2. Negative 6 plus 4 is negative 2. Is negative 2 equal to negative 2? Yes. So our answers are correct. It worked. Awesome. Okay. So there's the substitution method versus the elimination we've been doing. Would anybody feel that they would benefit from running through another substitution problem? You got it. Yes. Okay, let's do another one. Looking at this worksheet, let's see. Let's run through one where y is already solved for, because I know that's going to throw somebody off. Let's look at number 9 on this worksheet. Number 9, or not number 9, sorry, number 11. On this worksheet number 11, I have y equals 3 and y equals negative 2x plus 1. If I want to use substitution here, how am I going to do that?
So you're just going to plug 3 in where the y goes?
Yes. I already have y solved for. Y is 3. I don't need to solve for it again. I can just plug in 3 for y in my equation right here. So we're going to write 3 equals negative 2x plus 1. I'm still putting the second half of my equations equal to each other. It's exactly the same thing. It's just now one of my equations doesn't have as much on the other side. It just has the answer, 3. So now I have 3 equals negative 2x plus 1. How do I solve this? Good. Minus 1 on both sides. Those will cancel. 3 minus 1 is 2. Bring down my equals to negative 2x. And we divide by negative 2 on both sides. My negative 2's will cancel, giving me an x by itself. And what is our x value going to be? Negative 1. X equals negative 1. What's our y value? Y equals 3. They already gave us that. Nice. So what would our coordinate be? Negative 1. X comes first. 3. Y is second. So remember, x value in a coordinate always comes first. Negative 1, 3. Okay.
And coordinate.
Yes.
Yeah. I thought it's rising or wrong.
That is our slope. Yes.
Go up.
For slope, we go up and then over. But coordinates are, we're looking at the over first. Yes, yes, the x value. Okay. Do we have any other questions about substitution? Okay, if not, my assumption is going to be that you all understand this perfectly and you have no questions. So this is an excellent time to ask questions, to tell me that you want more practice, to, tell me if there's a part you're not quite getting.
No, I like it.
You like it. That's good. Okay. Are we feeling okay about this? We're all right? Okay. Well, in that case, let's do one run through of the graphing, make sure we understand that still as well, and then I am going to give you your exit ticket. So let's make sure we understand that. And what we'll do is just pick a problem from this worksheet, and I'm going to try it that way. So let me grab some graph paper real quick and just make sure we remember that process. Okay, so here's my graph paper. And let's look at, let me find one that has reasonable numbers. Let's do number 15, which is y equals x minus 5 and y equals negative 2x minus 2. So we're going to solve this by graphing. So the first thing I need to do is draw a graph. So I need, let's see, how many points? 1, 2, 3, 4. 1, 2, 3, 4. Okay. Whoops. Okay, here's my graph, and my y-axis is the one that goes up and down. My x-axis goes left to right. Let's make sure we remember how to graph a line. So when I'm looking at these equations, how do I start the graphing process? What do I need to identify in both of my equations?
Y-intercept.
Yes, my y-intercept. What else do I need to find?
Rise over run.
My rise over run, my slope. So my y-intercept and my slope. So in my first equation, y equals x minus 5, what is my y-intercept? Negative 5. That's the y-intercept. So where does my first point go? Negative 5 on the x-axis or the y-axis? The y-axis. So there's our first point, right at negative 5. And what is my slope? 1. When there's no number, there is 1. So my slope is 1. How could I write that as a fraction? 1 over 1. So my rise is 1, my run is 1. So I need to go where from here? Up 1, over 1. Now with a small slope, my recommendation will always be continue that pattern. Keep going up 1 over 1 and give yourself more points to go through because that will make your line more accurate. So I up 1 over 1, I'll do that again, up 1 over 1. Do it again, up 1 over 1. Do it again, up 1 over 1, up 1 over 1, up 1 over 1. We could even go in the opposite direction, this way, down and over, the opposite direction. So now I have tons of points. I'll know that my line is accurate. So I'm just going to trace over my points, and I have my first line. And this is my y equals x minus 5. So we've graphed our first equation. Now we want to look at our next one, negative 2x minus 2. Where do we start for this problem? My y-intercept. What is my y-intercept? Negative 2. Okay, so where do I put my first point? Yes, negative 2 on the y-axis. Right there. Okay, so I've done that. Now what? What is my slope? Negative 2. So what would my rise and my run be? Yes. So from my y-intercept, what way do I go? Down. So my rise is -2. When I have a negative rise, I'm going down, not up. So I'm going to go down 1, 2, and then what's my run? 1. So I go over 1. Oh, there it is. That's going to be my intersection. I'm going to just repeat that, down 2 over 1, down 2 over 1, and I'll connect my dots. There we go. So, can I see my solution now? I can. Where is it? Ah, it's right here. Okay, the values are -4 and 1, but which one is my x value? 1. And in a coordinate, the 1 being my x will come first. And my y value? -4. So that would be our answer, 1, -4. And we did that by graphing. Okay. How do we feel about that method? Feeling okay? Okay. Do we have any last questions, or do we feel like we need another one to see? We're also going to do a tomorrow. It'll be like a review day, a practice quiz over all 3 methods, and then Wednesday we will be taking our last quiz of the term. Today's the last exit ticket I'm going to give you, so exciting. Anywho, well, I am going to get you out early today. I'm going to go ahead and create your exit ticket now. You're welcome to take a little break while I'm making it and getting copies ready. After I do that, you guys are free to go. However, if you want to stay for more help, more practice, please do. Yes, and I'm going to make this exit ticket. Yes. Yes, absolutely. So this is your last exit ticket ever. Yes, but I'm gonna draw you a graph. Hey, so good to see you. Okay, names. Yeah, I can't believe how long that was at the daycare. It was so crazy. Just wild. So I'm going to give you guys the opportunity to choose whichever method you prefer to use here for this exit ticket. And let me just find a problem. That's good. Okay, so for your exit ticket today, I'm giving you 2 different systems to look at. You only need to solve one of the systems. You get to choose which one you want to do. You can choose any of the 3 methods to solve. If you want to graph, you can use the grid that's on this paper. If you decide to do substitution or elimination, you obviously won't need a graph. You can just use this as lines on your paper. So that being said, I'm going to go ahead and run some copies of this and bring it back. And when you finish, that is it today.